Hello. My name is Michal Pleban. I'm from Poland. I have been invited here to give you a little talk about a strange project that I have been working on recently. So first of all, thank you very much for inviting me here. It's a real pleasure to meet so many great people and to see so many great machines. And before I begin, you're making a photo of the hello screen? Okay, before I begin, I would like to show you two screens. They have been made on the same computer. I'm sorry that it's not the best quality. They're just photos of a computer screen. That's how you made screenshots in the 80s. And do you see anything strange, disturbing, out of place on those two screens? You should. Because on the first screen, you can see, obviously, it's a Commodore basic machine. It has a 6502 processor. But it also runs not on Commodore. And it even has a C drive. So it's a PC and a Commodore basic machine at the same time. How is that even possible? How can you run not on Commodore on a Commodore 8-bit machine? That's what I'm going to talk about today. And it all starts with a Commodore PAT, one of the first home computers, which was introduced in 1977, and has quickly grown to a big family of business computers, very successful computers made by Commodore. But sometime in the beginning of the 80s, Commodore realized that their CBM, PAT computer line was getting a little bit obsolete. So what they wanted to do was to introduce an upgraded system. And this was the Commodore CBM2. And it's a really very interesting machine in itself, because, for example, they were able to extend that 6502 processor to handle 1 megabyte of memory instead of just 64 kilobytes. And it has some other interesting hardware capabilities as well. It even has a SID chip, so you can play some nice music on it, which is quite unusual for a business computer. So this was going to be a quite powerful 8-bit business computer, one of the most powerful 8-bit computers ever made. And it also looks very nice. This is one of my machines. I have a few of them, and it's my favorite line of Commodore computers. So I have more. Really, more.
And this one is a pet in the middle.
Yeah, that's a pet in the middle. Yeah, you have two pets on the photo. But something happened in 1981. The IBM PC happened. And although it's comparable in speed and capabilities to the CBM2, it's a 16-bit machine. And of course, it was backed with the whole marketing machine of IBM. So it was quickly gaining popularity when Commodore was still working on its CBM2 line. But Commodore had one trick up their sleeve, which is highlighted here. You can attach a second processor to a CBM2 computer. And the PC cannot do that. And most of the computers back in the early 80s couldn't do that. And what is really, really interesting is that it is not specified what kind of processor you can attach to the machine. There can be any processor which just follows the protocol. So what they originally wanted to do was to attach Z80 processor to run CPM, but you can also attach Intel 88 processor. You could really attach anything you want, at least as long as it doesn't overflow the bus with too big frequency. So this is where the computer really stands out. The Z80 card never made into production, although we have the schematics, so maybe we can recreate it sometime in the future. But the 88 processor card did, and this is how the card looks like. That's original card made by Commodore. And how does it work? It's a very interesting architecture because you have two different processors from two different families running in the computer at the same time. And the only constraints are that only one CPU can access the main RAM, and only the 6502 processor has access to the I/O chips. But otherwise, you can do whatever you want with those two processors. So you can even run some software on them in parallel. It has never been done. There is no software which does that, but you can do it. If you are really very determined, you can run one piece of software on the Intel CPU, another piece of software on the MOS CPU, and then they communicate with each other and do interesting stuff. And normally, though, what it does is that one processor is running some kind of program from the main memory, and when it needs something from the second processor, it calls it using an interrupt. The second processor does its job, and then it gets back to the main processor. Normally, the Intel processor is running some kind of operating system and asks the MOS processor for I/O. But you can do it the other way around as well. You can have some kind of application running on the MOS processor, and then you can call the Intel processor, telling him, hey, I see that you are a big 16-bit processor, you have big processing power, so please do this kind of task for me. And the Intel processor will do whatever it has to do and return back to the MOS processor. This also has never been used in any kind of production application, but it's also possible. So it is a really powerful architecture, and it was created many years before the Commodore 128, which also has two CPUs. And yet this is even more powerful because you have a 16-bit processor running inside. The problem with the card is that it was never made in big quantities. So I estimate there are about 50 of them still existing today. It's a very rough estimate. And also they have bugs, which prevent some things to be done with them. For example, the numeric processor does not work, even though the card, if the card has a slot for it, if you insert the processor in it, it will just hang. That's the problem. So if you want to play with this capability of those computers, what can you do? What are you supposed to do when you have a very rare software, but you really, really want to use it anyway? No, of course, you clone it. So that's what Ruud Baltisen, a very smart guy living in the Netherlands, did. He reverse engineered the schematics of the boards, put them into Eagle, created a new version of the PCB from them, and that's how the end result looks like. What was really amazing about his work is that I soldered his card and it worked from the first go. So he made some improvements to the card as well. He made the math coprocessor work finally. He also made some little changes, but otherwise it's just the original card, but with Eagle files, so that you can spin around PCB, you can solder it, and it will work. So what can you do with the Intel processor card for the CBM2? You can run CPM 86, version 10 and 11. That was actually the main system that has been used on the card by the users. However, a few of them were there. And there has been a lot of development done on the CPM86 for CBM2. There's about 20 disks of software available now, with all kind of applications ranging from text editors, WordStar, for example, of course, and to C compilers, etc., etc. So that's really a big library of software you can use. But from the historical perspective, we know that CPM was really a dead end. And it's very good that they did lots of software for the machine, but right now we don't use much CPM anymore. So fortunately, what you can also do is to run MS-DOS on it. And that's the boot screen of MS-DOS 1.25. And of course, today we associate MS-DOS mostly with the PC platform. But back in the early 80s, MS-DOS was meant to be a universal operating system, just like CPM has been before, just like Linux is today. And MS-DOS was supposed to be run on a very broad range of computers. So these are all MS-DOS compatible computers from the early 80s, and each of them had its own customized version of MS-DOS that ran on it. Well, the problem is all those machines were not PC compatible. So even though it were MS-DOS compatible, they were not PC compatible, which meant that the version of MS-DOS had to be tailored specifically to those machines. And the applications which were running under MS-DOS were normally expecting the PC hardware underneath. So even though they were very great computers, we don't have them around anymore. And specifically, Commodore CBM2 is absolutely not PC compatible, even with the Intel processor card. In fact, it is about as incompatible as possible. If you look at the hardware description, you can see that apart from the processor, about everything else about those computers is different. And the especially troubling part is that on the PC you have all the I/O attached to the Intel processor, but on the CBM2, all the I/O is attached to the MOS 6509 processor. So Intel processor cannot see anything apart from the memory. And of course, there's so many more differences. Even the interrupts are wired differently. The disk drive is different. Even the underlying format of the disk drive is different, because on the PC you use MFM disks, but on the Commodore you use GCR disks. So it means that you cannot just insert a disk from a PC into a Commodore disk drive and read it, because it will not work. So basically, what can you do with this kind of incompatible machine? Well, of course, you can run MS-DOS 1.25, which has been written for that machine. You can run some MS-DOS command like dir. Not very exciting, but yes, you can do that. You can use Microsoft Assembler, which is actually included on a Commodore disk. You can write Microsoft Basic Interpreter that has been ported from CPM.
Entschuldigung.
Sorry.
Keiner sagt mir Bescheid. Oh. Ja. Ich hinten und weine in der Ecke.
Okay. So you don't find the Microsoft Basic Interpreter on a Commodore disk, but you can download it from the internet, and it works. You can even use Microsoft Basic Compiler, but you cannot use any application compiled by this compiler, because even though the compiler itself runs on plain vanilla MS-DOS, the applications that it produces required the computer to be PC compatible. So it's quite a pointless exercise in itself. You should be able to use the first version of WordStar. I was not able to confirm it because I couldn't find it for download anywhere, this very old version, but it was ported from CP/M, so theoretically it should work. And that's about it. So it's not a very exciting possibility. What I would really like to do, since I already have an Intel processor card in the computer, I would really like to run modern MS-DOS, modern PC applications on it, and not just this little useless stuff. So these were the design goals that I set for myself. I wanted to run PC applications, but I also wanted to run the existing software that exists for the card so that the whole solution would be backwards compatible with the existing software. So I still want to run MS-DOS 1.5 if I really, really want to, and CP/M as well. And I want to retain hardware compatibility as well, so that everything that I create runs on the original card. So that's where we defined the goal of the final goal of the project. To run modern MS-DOS versions and PC applications, but by making the CBM2 computer PC compatible in software only, without any modifications to the underlying hardware. Can you do that? Yes, you can. This is a quick blueprint of what is required to make the computer, or basically any Intel 8088 computer, PC compatible. So of course you need a PC BIOS. You need to implement PC BIOS interrupts for interacting with the screen, disk, keyboard, serial port, and so on. In this case, in the case of CBM2, you also need to implement the 6509 code, because this is the processor that accesses the I/O. So you have to write two different pieces of software which communicate with each other and provide a translation of IBM PC BIOS interrupts and interface to the 6509 I/O library. You also need somehow to be able to read PC disks, so you need to emulate the PC disk drive somehow. I will show you later on how it's done. And a lot of other stuff, like for example dealing with a character ROM, which on a CBM2 has only half of the characters that you have on a PC. Because on a PC you can use a full 256 character, and there's a lot of strange things in it, but on a CBM2 the last bit is used for inverse video, so we have only 128 characters, and somehow you need to squeeze the PC character set into that. Sorry, you have a question?
Yeah, sorry. The DOS 1.25, didn't this one already have a BIOS, or how did it work? Was it?
It doesn't have a BIOS because it's not necessary to run MS-DOS. What it does is it has a custom IO.sys file, which communicates with the 6509 processor. Generally, what you did in those days, for every computer you wanted to run MS-DOS on, you would have to write your own IO.sys file. And it would be very specific to the machine that you're using. So on a PC, the IO.sys file communicates with a PC BIOS. On a CBM2, the IO.sys file communicates with the IPC hardware and calls the 6509 processor. And on any other machine, it would do something very machine-specific to achieve the same goal. So that's what happens. So of course, you can disassemble the CBM2 IO.sys file to see how all the stuff is being done. That was a part of the things that I had to do in order to discover how I/O functions work, but that's about it. There is no BIOS at all. Yeah, so coming back to the character ROM, a very important thing if you really want to run MS-DOS is to have a / character. And the CBM2 doesn't have it. So you have to deal with, even with little stuff like that. Huh? It stopped working for some reason. But I can use keyboard.
It's switched off.
I don't know. Yeah? No, it's on. Okay, but anyway, I have a keyboard here, so not a big problem. This is how you implement PC BIOS. So basically, this is a little piece of code that takes a PC interrupt and translates it into IPC calls to the 6509 processor. This is one function to scroll the screen. You need just to write a few dozen of those, and you have a PC BIOS. So that's what is needed to run MS-DOS. This is the list of interrupts that you have to implement in order to have a PC version of MS-DOS working. If you get those right, you have a guarantee that MS-DOS will boot on your machine. You can, of course, implement some others which are optional, which are not necessary. For example, CBM2 doesn't have a real-time clock, so it really doesn't make any sense to implement interrupts for a real-time clock. But if your machine has it, you can also write those interrupts as well. But this is the minimum. If you have this, MS-DOS boots. You also need to access PC disks somehow. So this is what I did. There are many different floppy formats for a PC. But what you can do is just to copy them sector by sector to a Commodore GCR diskette. You can create a Commodore disk image this way on your computer. And you can download it by a serial cable. Write them then sector by sector to a Commodore diskette. Of course, you need geometry translation and stuff like that because the disk geometry is very different on Commodore. But basically, this is how it's done. You just lay the sectors sequentially on a Commodore disk. Of course, a PC diskette has 512 byte sectors, and Commodore is half of that. Just a few little translation routines that are needed to get the disk working. And if you have the image, you can download it to the CBM2. It takes only 40 minutes to write it to the disk drive. Not a big deal. Of course, you need to implement the character ROM, as I said. That's basically how you do it. The upper half of the screen is the 128 characters that are needed to emulate the PC character ROM, at least most of the characters which are most often used. There's still something that needs to be done, as you can see on the list, but basically these are the steps that you take to make the machine PC compatible. And this is the result. You can see MS-DOS or PC-DOS version 3.3 booting on the CBM2. This is the moment when you all say, wow. And it works. You can boot PC-DOS on it. You can run whatever commands are included in MS-DOS. You can even partition the SD card with F-disk. Everything works. But there is a little problem when you want to run some other applications. Yes?
How long did the check disk work on the Commodore disk drive?
Sorry?
You run check disk, right?
It's actually running on an SD card.
Oh, okay.
You can see it's a C drive, and it has 32 megabytes. So it's an SD card and it runs like 10 to 15 seconds on it. If you run it on a diskette, it may run a little bit longer, but check this doesn't really do much stuff with the diskette. It just reads the FAT and reads the directory. So it will be quite fast on a diskette as well. We will have I think we will have a computer running the card today later. Is that true? Yeah. So you can see then for yourself. So you can run MS-DOS, but if you want to run some more interesting applications, you quickly run into a hardware problem that cannot be overcome with software alone. Most programs want to access the video memory because writing stuff to the screen using PC BIOS interrupts is really slow. And in the days of original PC, XT, AT, most people preferred to access the video screen. If you want to have a full text editor or something more sophisticated on the screen, that's the way to do it because the PC BIOS is too slow. And of course, you don't have any kind of video memory on the CBM2. The CBM2 sees only the main RAM. There is nothing on the location where the PC expects the video memory to be. And the actual video hardware is on the 6509 processor side. So what can you do about this problem? You can implement a tiny little hardware hack, which looks like this. What it basically does, it inserts a little chip into the Intel processor address bus, and it cuts the few kilobytes from the top of the memory and it places them into the location where the video memory is on the PC. So now the processor sees a little less RAM, but instead it sees this RAM where the video memory is expected to be, whereas the 6509 processor still sees the whole memory as it did before. So what it can do now is to run a routine that takes the contents of this memory and move it to the actual video memory. If you run this kind of routine periodically, you will basically have a video memory emulation on the machine with just a very tiny little one chip placed on the board. And if you do that, you basically have an MDA card emulation in the hardware. So any kind of software that needs to play with the screen directly can do it. I hope you like movies. I like them too. So I made a little movie for you, which you can watch now. This is a movie which shows the hardware and software in actual action. So you start with Commodore Basic, of course. You can load the software. This is still the 6509 processor loading all the files into memory. But here the magic happens. We have bootstrapped the Intel 88 processor, and whatever else is happening now is being done by the Intel processor. So now it's loading PC-DOS from the SD card. It takes about 20 seconds to boot. So you have to listen to me droning about it. Oh, it started. You can see the contents of the SD card. There are some interesting directories on it, which we will explore right now. Yep, we have Turbo Pascal running on the machine. Yeah, this is Turbo Pascal.
GW basic.
You can also, of course, you can have a full screen editor. because you have video memory, so you can edit some file. We will do some little modification to the file, just to prove that it's possible. Okay, nothing very sophisticated, just add some exclamation marks. And then we're going to compile this into an executable file. Yeah, we change some options to compile it to a file, not in a memory. Yeah, we save it to the disk. And we created an executable file from this source. And we're going to run it. And it works. What else can we do? Let me see. Yes, what we're going to do now is to run Datum Commander. It takes a little while to load because it's a big piece of software. But
in the lower right is your debug.
yeah, it's a debug showing that it's loading something from the SD card. And that's Datum Commander. You can browse the disk. Let's create a directory. Yeah, it has been created. Let's copy some files to it.
What does the character on the lower right corner show?
It's just a debug output for the moment showing that the SD card is being accessed. So that you can be sure that it's not hanging. You can view the contents of the text file. Okay, you can copy it to some directory. You can delete it if you really want as well. And that's Datum Commander running on the CBM2.
Very nice.
So the conclusion is that you can take basically any kind of hardware that has Intel 8088 or 8086 processor, and with a pure software solution combined with just a tiny little hardware hack to change the memory map, you can make the computer PC compatible enough to run those kinds of PC applications. So if only those guys would hire me as their chief engineer. That's all for today. This is how you can reach me. That's also a GitHub address where you can see the code and the Eagle files that I have been showing you. So the whole project is on GitHub. It's an ongoing project, so I'm posting periodical updates to it, checking off the items from the to-do list. So that's all. If you want to talk about it, if you want to ask questions, I'm here the whole day today, and you can email me or reach me in other ways in any case. Thank you very much for your attention. Thank you again for inviting me here. I see that there's a question over there.
Yes. Is it possible to convert FreeDOS to the project?
It should be. I have looked, I have given a cursory look on the FreeDOS source code, and I don't see anything tied directly to hardware. What I saw was only calls to the PC BIOS interrupts. So as far as I know now, it should be very well possible to run FreeDOS on it as well, provided that it fits in the memory. I don't know exactly what are the memory requirements of FreeDOS, but if MS-DOS runs, I suppose FreeDOS shouldn't be much bigger, especially if you remove some stuff that you don't need, like hard disk and so on. Yes, my opinion at this point is that it should run. Sorry, one more question from him and then from you.
Yes. Is it possible to make a card for C64 and C128? I think C128 can read real MS-DOS diskettes.
Yes, the C128 can read MS-DOS diskettes with the 1571 disk drive.
Yes, and 1581. I think it's
Yes, that's also true.
I think it's possible to read DOS disks on C64 with a 1581.
Yes,
The real disk.
that is true. And in fact, okay, that's so taking so long. And in fact, what you see here is a 1581 disk drive connected to this to the CBM2.
With the converter.
Yes, with the IEC cable. So it is possible to read PC. It would be possible to read PC disk with it. The problem is, of course, that these are the serial drives.
Yes.
So they are even slower than IEEE drives, which are already very slow, because you have to, for example, read every 2 sectors to emulate 1 PC sector. So it would be painfully slow to use this kind of solutions, but it would also be possible as well. There's nothing here that prevents us from doing it except time. Your question.
Have I understood you correctly that the only difference between the MS-DOS versions for non-PC compatible hardware is a different IOSys file? So
Yes.
Okay.
Yes, that is true. Plus, of course, some applications, for example, format on many non-PC compatible systems needs to be tailored directly to the hardware in order to format floppies. But otherwise, the difference are in an IOSys file. And the IOSys file provides a uniform API to the MS-DOS file, which should be hardware agnostic. Whatever it needs to do with hardware, it calls the IOSys. And only IOSys is specific to the machine.
I see.
Okay, you again.
How have you connected the 1581 disk drive to the CBM2? So the CBM2 has only an IEE 488 connector and not an IEC?
Yes, you can create a cable from the tape port, which is not used. So you have some free I/O pins. You connect them to the IEC bus, and there is a piece of software floating on the internet. You can download it, for example, from Ulrich von Bassewitz's website, which uses this kind of interface to access the serial drives. So I have taken his routines and I put them on a cartridge. I saw that some of you are using actually this cartridge here. So you boot the computer and it already installs the routines into memory, which allow you to use both IEEE and IEC drives on the same machine. That's how it's done. And of course, it is very slow, but it works. As you can see here, it's not a very clear picture, but you can see a directory listing being loaded from the 1581 drive.
Okay. It's not using the fast serial because...
No, it's not using a fast serial. I suppose it could be using, but the routines do not support it. So it's one of the hundreds of projects for the future. Okay, any more questions? Great, and thank you very much again for your attention, for inviting me, and have a nice day here. Thank you very much.